Hello students, in this session we will discuss about another advanced or enhanced data model that is called as temporal databases. So temporal databases, it is a different type of database where we include the time aspect of the inclusion of data into the database table. So here we will be discussing about the representation of temporal databases and the various concepts associated with the temporal databases. So as I was mentioning, temporal databases usually deals with the time aspect, the representation of data with the specification, that is the time details. So every data that is present inside a temporal database will be having its associated time. That means it maintains the history of data when that particular event occurred or when the data was added into the database, how this data can be, or when this data was in the real life it was valid, etc. For all these purpose, if we want to maintain some history of these informations, we require the time details that is also appended to the existing database table. So similar concept is maintained by using the temporal database concept. So in these temporal databases we need to consider the different time aspects. So we will be discussing about the time representation, the calendar concept, and the various time dimensions. So time representation, how we are representing the time, what are the different contents of that time. Then calendar, what is the purpose of using calendar, how it is being maintained, what are the procedures to be followed for the maintenance of that calendar. Then what are the different dimensions of time, how we can represent the time in different ways. So time is considered as an ordered sequence of points in some granularity. So what is actually a time? So if you say time in our clock or watch, how we are looking into the time, it is having some ordered sequence of points. In our clock we are having some ordered sequence of points. So these points may be some minutes or seconds or hours. So we are having some ordered sequence of different points. So sometimes we can represent it as some seconds, first second, third second, etc., etc. Some ordered sequence of points in some granularity. What is this granularity? Granularity means in which way there must be some dimension, like it may be a point difference, that means first, second, third, fourth, fifth, etc. There is a difference between these numbers. What is that gap? With some granularity. Sometimes we can call the time as first week, second week, third week. The granularity is week. We are having some days in between. Sometimes we can represent the time as January, February in different month. Now the granularity is different. For a clock, the granularity is like seconds, minutes, hours, etc. In days in the week, we will be having day 1, day 2, day 3, day granularity. In the month purpose, we are having month 1, month 2, we are having month granularity. So we can represent the time in different granularity, but that represents an ordered sequence of points, and that granularity may be different, depends on the situation. We use the term chronon instead of point to describe the minimum granularity. So we are not going to discuss or we are not going to use the term granularity for representing these points. that means we'll be using chronon. That means that is the general term that we are using for representing these points to describe about the granularity. Like the chronon may be seconds, it may be minutes, it may be hours, it may be days, it may be weeks, it may be months, etc. So before moving into the details regarding the temporal database usages in database concept, we will see how we can represent the time in detail. So we know, so we have seen that chronon or granularity concept. Now we know calendar. What is a calendar? A calendar organizes time into different time units for convenience. What is the content of a calendar? Calendar normally consists of time. It represents the different days, the specialities of those days. Then it is having some order. Some granularity will be maintained on that particular calendar. So different calendars are available in the world. So like the calendars like Gregorian or Western calendar, Chinese calendar, Islamic calendar, Hindu calendar, Jewish calendar, etc. All these are different calendars that are followed in different countries, because different countries they are having different time zones, and they'll be having different granularities that may be followed on all these. So even in our state itself, we are following Western calendar, as well as we are following Malayalam calendar also. They are having different values in different situations. So according to the user convenience, we are actually following different types of calendars, but all the calendars represents the organization of time unit for the convenience of the people who are residing on that particular country. Now there are actually two types of events in relation with time. That is, the first one is the point events and second one is the duration events. So based on this time factor, we can represent two types of events. One is the point events and second one is the duration events. So what is the point event? If an event occurs on a particular single time, that is called as a point event. If something happens on a particular time. So one example given here is a bank deposit. Money is being deposited into a particular account on a particular time. So that time will be a single time point. Exactly on that particular time, the amount is being deposited. It happens on that particular time only. So similarly, a series of point events can form a time series data. That means in the first hour, second hour, third hour, fourth hour, etc., we are having the different occurrence of different point events. So we can form a time series data by combining all these point events. Now we will compare point events with duration events. So what is duration event? Duration event is associated with specific time period. If something happened between two days, all the bank transaction between 1st August to 31st August 2021, this is associated with the specific time period. We'll be having a number of events that occurred within a specified duration. So this time period will be having a start time and an end time between 1st August and 31st August 2021. There is a time period, or there will be a gap between two different times, that is the start time as well as the end time. So when we consider different database related applications, there will be several events that happens on a particular point, that is called as point events, and there may be several events that is to be considered within the range of 2 times or 2 days, that can be called as duration events. Now among these time, we can divide this time into different types. First one is called as a valid time and second one is called as a transaction time. So for a temporal database concept, these two times are very important. That is the valid time and transaction time. And third, we are having a bi-temporal database also. So what is this valid time? Valid time means it is the time that the event occurred or the period during which the fact was considered to be true in the real world. This is the important point. Valid time means some event occurred or some duration event that occurred in the real world. That means one employee was working in a particular organization from a particular date to another date. This is a duration event that happened in the real world. An employee was working between these two dates. Similarly, some point event also, whatever be, whether it is a point event or a duration event, if we are representing the time of the exact occurrence of that event in the real world, that time can be called as valid time. And a temporal database using this interpretation, that is the valid time interpretation, is called as a valid time database. The database that follows the exact time of the occurrence of the event in the real world is called as valid time database. Now look into the second type of time, that is called as transaction time. There is a slight difference. It is the value of the system time clock. It is the time clock when the information is valid in the system. For example, one employee was starting working in an organization from 1st August 2021. For example, it is a value of the system time clock when the information is valid in the system. So this is the day from which an employee is working in a particular organization. But assume that sometimes this data was entered into the system, into the computer database on a previous day. Maybe on July 28, the data was entered into the database. So this July 28 is the transaction time when the data was entered into the system. That means it is valid in the system. But in real life, he is working from 1st August 2021. But in the system, it was entered on the date July 28. Maybe it may happen after this 1st August also. So one employee joined to the institute on 1st August 21, but it was entered into the system on 2nd August. Now this 2nd August can be called as the transaction time when the information was valid or entered into the computer system. So the time in which the data was inserted or entered into the computer database is called as transaction time. So a temporal database that uses this interpretation is called as transaction time database. So one example temporal database that follows valid time, that is called as valid time database, and those database that follows the transaction time, it is called as transaction time database. Now we are having a third category, that is called as bi-temporal database. The databases that deals with both of these two dimensions. That means it uses both the valid time as well as the transaction time. So those temporal database that uses both valid time concept as well as transaction time concept is called as bi-temporal databases. So temporal databases are mainly categorized into three. One is valid time databases, second one is transaction time databases, and third one is bi-temporal databases. Now, incorporating time in relational databases using tuple versioning. So how we can utilize these temporal databases in our relational database system? It is done by using a concept called as tuple versioning. Tuple versioning, that term is very important. Tuple versioning means different versions of a single tuple itself is maintained inside the database table. Different versions of a tuple. Different versions of a tuple. So normally in a traditional database table, what we are doing is in the employee table, if a new employee is being entered, his data will be added. One row will be inserted. Now, if that employee is moving into some other department, or if any updation happens to the same employee, it will maintain the previous tuple there itself and will create a new tuple for the same employee with the new updation. That is called as tuple versioning. So if any updation happens, it will become the history. That tuple will be maintained and it will create a new tuple, a new version of the tuple with the newly updation. If any further updation happens, that too will be remain there within the system. It will maintain it as a history tuple and a new tuple will be created with new updation. So maintenance of multiple number of tuples or tuple versioning is the main concept behind the temporal databases. So here we need to consider both valid time as well as transaction time relations. So first of all, we'll discuss about valid time databases where we are using valid time relation. So in order to maintain this valid time relation or valid time databases, what we are doing is we are adding two special content or attribute value into every tuple that is present in the database table. That is, one attribute that is being added is the valid start time, and second one is the valid end time. So we are maintaining a version of a tuple. So we are having some rows available. For each row we will be having one more attribute that is for representing valid start time, then one more attribute that is used for representing valid end time. We will see that in detail on the next slide. So let us see some example. So we are forming some temporal databases. So different types of temporal relational databases we are representing. There are three things. One is the representation of a general concept for an employee valid time database, B for an employee and department transaction time database, and third one is employee and department for a bi-temporal databases. Now the employee table is given a different name, that is employee underscore valid time, VT. It consists of name, SSN which is the primary key, salary, department number, supervisor SSN. Then we are adding two more attributes. One is valid start time and second one is valid end time. So for every relation we are adding the valid start time and valid end time. So look into the department temporal database relation, that is department underscore VT, that indicates valid time relation. So this name is given in this way just for representing it as a valid time relation. You can provide any name. So department underscore VT, department valid time relation. department name, department number, total salary, manager social security number. Then we are adding valid start time and valid end time. So this is the way in which a temporal database in the valid time database concept being represented. So remember, for every relation, if it is following valid time relation, add two more attributes, valid start time and valid end time. So valid time database means the in the real world these informations are valid during valid start time and valid end time. Okay, now look into the second one, that is B. Again we are representing employee and department relation in transaction time database scheme. That is why the name is given as EMP_TT, transaction time relation, department_ transaction time relation. So here in this concept, what we are adding is, towards the end of this relation we are adding two more attributes, which is given the name as TST and TET, that is transaction start time and transaction end time. So look into employee table, name, SSN, salary, department number, supervisor SSN, then transaction start time and transaction end time. The duration. For department table, department name, department number, total salary, manager SSN, again transaction start time, transaction end time. So these are the duration of, or the difference between the transaction, the start time and the transaction end time. Here we had the real world scenario that time. Here the database entry, that is the exact occurrence of the transaction within the system, that time is being represented. Now in the third case, for the bi-temporal type of database system, we are providing the name like EMP_BT, that represents bi-temporal, department_BT, department bi-temporal database relation. What we are doing with this bi-temporal, as I was mentioning before, it consists of both concept, that is the valid time information as well as the transaction time information. So along with employee name, SSN, salary, department number, supervisor NNN, a valid start time, a valid end time, then a transaction start time and a transaction end time. So 4 attributes will be added into that particular relation, the relation that follows bi-temporal database schema. So into the department name, department number, total salary, manager SSN, valid start time, valid end time, transaction start time and transaction end time. So this is very important, how to represent a temporal database in 3 different database schema. One is valid time temporal database schema by adding valid start time and valid end time to the end of all the relations. Now in the case of transaction time database schema, towards the end of every relation we will be adding transaction start time and transaction end time into every relation. Then for the case of bi-temporal database schema, with every relation towards the end we are adding 4 attributes, valid start time, valid end time, transaction start time and transaction end time. Now look into a real-time example. We will directly take one table that consists of some datas. So this is the way how we are representing tuple versions, or different versions of tuple. So these two are examples of valid time databases. Employee_valid time, department_valid time. So only difference is here we are having some content also, some data is being represented. So we will see what are the contents of valid start time and valid end time. So you can see, I'll take one example. Smith is an employee. This is his SSN salary. He is working in department number 5, and his supervisor whose SSN is given here. Then valid start time. Valid start time means in real time he started working on the department number 5 or whatever it be. Okay, from the date 15/6/2002 to 31/5/2003. So during this period, the employee Smith was working with this SSN with salary 25,000, department 5, with supervisor during this period. So directly we are representing the starting date and end date in real time scenario. Now we can see, just after that we can see another tuple for the same employee Smith. Now this is another tuple version for the first tuple. Look at this row, this tuple in detail. Why did we require this second tuple? Maybe because of some modification added to the first tuple. Something was changed for the employee Smith. That is why we are creating a new tuple, because some variation, something happened. Either he have changed the department, or he got some salary change, or his supervisor was modified. Whatever it be, a new tuple is being formed. Something was changed for the employee Smith. Look at the difference. So Smith he remains with the same SSN. Now look at the salary. His salary was modified to 30,000 from 25,000. He is again working with department number 5, and his supervisor is also same. Now from 31/5 up to 31/5/2003, he was having 25,000. Next date, that is 1/6/2003 onwards, he got a new salary. So now this is the latest tuple. Now you can see that what is his valid end time. Currently he is working with this strategy. Now the valid end time is given a special value that is called as now. If any tuple in the temporal database consists of a special value now, that indicates this is the current tuple version. This is the current tuple version. Okay. Now if any of the tuple that consists of valid end time with a date, that means that is a history that was happened before. So currently active tuple will be having the valid end time with a special value that is called as now. Now we will look into another employee Wong with SSN salary 25,000. He was working in department number 4. His supervisor 28/99 to 31/1/2001. Okay. Then again at second version something was changed. His salary was changed to 30,000. He moved to department number 5. Two changes from 1/2/2001. Next just after 31/1, 1/2/2001 to 31/3/2002. That is also history. Now again some more changes applied. In the next tuple version, his salary was modified to 40,000. He is working with same 5th department. His supervisor also changed. That is from 1/4/2002 to valid end time is now. That means this is the current active tuple. So for every employee, different number of tuple versions are maintained. Any version with valid end time with a special value now is considered as the current tuple. So this is the tuple that we are representing in our normal traditional database system. we are always representing the current version. But in temporal databases, we are maintaining the history information also. So if you want to deal with those employees who was working before, we require the history. By looking into temporal database, we can manage the database table with history information, their time, at what time he was working on that particular department, during which period he got this salary, and during which period he was moved or changed to some other department, etc., etc. All these informations can be manipulated on this temporal database table. Now we can see another employee Brown with SSN, salary, department number, supervisor SSN, then his valid start time, then valid end time. That means in the next row another employee is given. What is happening is Brown, he left the company because he is not having any other tuple with now. That means he left the company on 10/8/2002. He joined on 5/2001, then 10/8/2002 he left the institute. But if he was working there, one more tuple was added with some changes. Otherwise, he is currently starting from one particular date. He is still working there. This field will be now. But now this indicates he is not in the company. Now again, I can see Narayan is another employee whose SSN, salary, department, supervisor SSN. Then from 1/8/2003 to now, that means currently he is working in this department with all these details. So this is the currently active tuple. This is for the employee valid time relation table. I hope it is clear. Employee valid time representation of employee database schema. Very important thing, the meaning of valid start time, how it is being represented, valid end time, two representation, either an end date or now. We can have any number of versions of tuple. Just for representation, we have given 2 for Smith, 3 for Wong, and 1 for Brown and Narayan. We can have, so whatever changes apply. So if one employee is working for within an industry for 10 years, he will be having different versions of tuples. Sometimes the salary was modified, sometimes the department was modified, sometimes the supervisor was modified, etc., etc. As and when some changes apply to that particular employee, his history tuple will be maintained and new one will be modified with valid end time as now. Later it will be changed, so the previous one will become history and a new tuple will be added into the temporal database. Similarly, for department valid time relation, you can see for the research department, the department number 5, manager is this one, and from 29/2001 to 31/3/2002, this is the strategy of research department. Now it is history because we are having a valid end time. Now the same department research with department 5, his manager, that means the research department manager was changed and the new manager joined the organization from 1/4/2002 and currently he is the manager. That means this is the current version of tuple for the department research, and this is the history version. During this period, this 8866555 was the manager of the department 5. From 1/4/2002 onwards, a new manager came into the department research. I hope it is clear. Now some explanation is given that was already mentioned while explaining that example, but once again, in employee valid time, every tuple we represents a version of an employee's information that is valid in the real world only during the time period between the valid start and valid end time. The current version of each employee typically has a special value. So now is a special value that is given as the valid end time for the current version of each employee. That is current version. That means that is the status now. So if I require something for the current period, I will be considering that particular tuple. And this special value now is a temporal variable that implicitly represents the current time as time progresses. So every time this time will be varying, valid end time will be varying. So time, each second that value will be changing. That is why it is given as now, because every time we cannot represent on a single row. So now if I require that particular tuple, that current time will be taken. The non-temporal employee relation would only include those tuples from the employee valid time relation whose valid end time is now. So if we are using a normal database relation, normal employee relation, it will include only those tuples with valid end time is now. Only the current version was actually being considered in our traditional database relation. Whenever one of more attributes of an employee are updated, rather than actually overwriting the old values, what we are doing is, as would happen in a non-temporal relation, what we are doing with normal relation, we are simply overwriting that. If I am modifying the department, we are simply modifying that. If we are changing the salary, we are simply overwriting that. Here what we are doing is, the system should create a new version and close the current version with a valid end time. You have seen that. It is to indicate that the version has become a closed or history version. So whichever tuple with an end time, valid end time, is a history version. If an update is applied to the database before it becomes effective in the real world, if an update is applied to the database before it becomes effective in the real world, it is called as a proactive update. So these are related to the transaction time databases. So I have not taken a separate example for transaction time. Transaction time database also follows the same thing. There is a slight difference. I will show that while explaining bi-temporal databases. There actually we are including both valid time as well as transaction time versions. So there we can see that difference. So if an update is applied to the database before it becomes effective in the real world, that means an employee joins on 1st August, but it was updated on the system 2 days back. That means that type of update is usually called as proactive update. If the update is applied to the database after it becomes effective in the real world, it is called as retroactive update. That means employee joins on 1st August, but it was updated on 4th August. It is called as retroactive update. If an update as well as the real-time thing happened at the same time, it can be called as a simultaneous update. If something happens and the updation was also happened at the same time, it can be called as a simultaneous update. So transaction time relations, whenever a change is applied to the database, so I have not taken a specific example for transaction time relation. So whenever a change is applied to the database, the actual timestamp of the transaction that applied the change is recorded. Whenever a change is applied to the database, the actual timestamp of the transaction that applied the change. So here in the case of transaction time relation, we are not only having the date, along with date we are having the time also. We are considering timestamp. Timestamp means the date, month, year, the time with hour, minute, second, etc. All these informations are applied. That means if I am doing a transaction, so you will be remembering when you are getting some credit information message from the bank it will be providing the time in detail in timestamp format. Okay, so if one insert happens, that exact timestamp will be appearing on the tuple for transaction time relation. So such a database is most useful when changes are applied simultaneously in the majority of cases. For example, real-time stock trading or bank transaction. Bank transaction, if some credit happens simultaneously, the database will also be updated. Both real-time as well as the transaction time will be same. Now, a transaction time relation consists of transaction start time and transaction end time. As I was mentioning in the previous employee first table, transaction start time as well as transaction end time, whose data type is typically timestamp. In the previous case, in the valid time, we are representing only date, but in the case of transaction time relation, we are representing each transaction start time and transaction end time with a timestamp with all the informations of time that includes year, month, day, time in hour, minute and second. And the current version of each employee typically has a special value UC, that is until changed. So for valid time relation, the current version is represented as now. Similarly, in the case of transaction time relation, the current version is represented as UC, a special value that is until changed as its transaction end time, which indicates that the tuple represents correct information until it is changed by some other transaction. If any other changes or any updations applied to that particular transaction, it will be ended with a transaction end time, and the new tuple will be added with the end time as until changed. Now you will see an example for bi-temporal that consists of both valid time as well as transaction time relations. Both are mixed, so that is why this example we can see both valid time as well as transaction time informations. So look at employee bi-temporal and department bi-temporal. So this is given in, this is wrong actually, department underscore bi-temporal only. So employee bi-temporal, we can see Smith SSN, salary 25,000, department number 5, supervisor SSN. Then in real time he started his job from 15/6/2002 and valid end time is given as now. In real time he is currently working in the department, and his transaction start time, look at here, he joined on 15/6/2002, but transaction start time was 8/6/2002. This was happened before, around 7 days before it was submitted to the system on this particular time. And his transaction end time, that means on 4/6/2003, at this particular time on the database his end time was written, but currently he is working. That means he is moving actually, but it was changed in the transaction, in the relation on this particular date, but he is still working there. Now look into the next one, Smith. Again we are having one more tuple with SSN, same salary, department same, SSN same, then valid start time 15/6/2002, and here we can see the valid end time, he is up to 31/5/2003 only he was valid. Now this now changed to one date, in real time he is not there, and is transaction start time, that means you can see that the same time when the database was being updated a new value is being updated or something was changed, it happens. That means the transaction end time and the transaction start time of the next tuple version will be same, exactly the same, because these two occurs at the same time. I am doing one updation, previous one closed, new one started, that happens at the same time, and the transaction end time is until changed. Again I can see Smith with all these details, his salary was changed. So once it's 2003, currently he is working. Then his transaction start time, 4/6 2003, the same thing. Here we are not having any change, transaction that database that was not being changed. So his salary was changed, he is working now, it is not being changed. It may be modified on a different day. Similarly, we can refer to these changes in another employee Wong with these differences. We can see transactions, valid start time, valid end time. For some cases, we are having two dates, history, some with now, that is currently valid in real time. In this session, you can see transaction start time and end time, that is history version, and transaction start time and until changed, which is the current version of the employee. Similarly, for department bi-temporal also, so you can see that the second one, transaction time relation, in this example itself, we can see these with transaction start time and transaction end time. Also look at department bi-temporal table, research 5, manager, valid start time, currently he is research, currently this is the status. Then transaction start time 15/9/2001 to 28/3/2001, it was modified. Then again one more version, on a particular day the research department was having a valid end time, and these two remains the updation on database until changed. Then again a new manager from 1/4/2002 in real time till now, and database update is not being done on that particular case. I hope it is clear. The examples, so very important concept in relation with temporal databases: valid time relation, transaction time relation, and bi-temporal relation. 3 different types of temporal databases. Now incorporating time in object-oriented databases. So far we are discussing about relational databases, how we are adding time information into the relational database system by using above 3 methods. Now how we can add this time information in object-oriented databases? It is done by using attribute versioning concept. In relational databases we are following tuple versioning, but in the case of object-oriented databases we are following attribute versioning. The same attribute will be having different versions. A single complex object stores all temporal changes of the object. So we can have time varying attribute as well as non-time varying attribute. So example for time varying attribute is age. As time changes, the age will also become changed. So we'll be having different versions of the age attribute. So every day age will be varying. So we should have different version of age attribute. Non-time varying attribute means there won't be any change. So date of birth will always remain the same. It does not changes over time. So there are 2 types of attributes. one with time varying and second one with non-time varying attribute. So that is all about. So we are not going to discuss in detail about object-oriented database or temporal concept that is incorporated in object-oriented databases. So we were discussing about a second enhanced data model that is called as temporal database model, where we are following the time aspect for maintaining or representing data in relational database table as well as object-oriented database databases. So different categories of temporal databases and the importance of temporal databases was explained in this session, and this is a very important concept of database because in many real-time situation, many real-time application, we require the history information. So that is why we require the concept of temporal databases. So in the next sessions we will be describing about further different types of enhanced data models in detail. Thank you.